Imagine a destination so close it fills our telescopes, yet so far that even light needs millions of years to arrive. Our nearest major galaxy, Andromeda, drifts just over 2.5 million light-years away. Some tiny dwarf galaxies do lie closer, but when people say nearest galaxy, they mean this sprawling island of 1 trillion suns. A light-year is distance, not time, how far light travels in a year. And Andromeda is 2.5 million of those. Before we talk engines or crews, feel the scale. We are staring across a gulf so wide that our fastest signals are still slow. 1 light-year is about 9.5 trillion kilometers. Stack 2.5 million of those, and you begin to grasp the problem. Drive a car at highway speed? You'd need quadrillions of years. A jet airliner? Still quadrillions. Even our record holders, Voyager at roughly 17 kilometers per second and the Parker Solar Probe peaking near 190, barely scratch the surface. At those speeds, Andromeda is, for practical purposes, unreachable. Physics adds an absolute. Nothing with mass outruns light. Special relativity caps our top speed and punishes every attempt to get close. Concepts range from 1,000th of light speed up to a few tenths in optimistic studies. 0.201 c to 0.2 c. Even at a blistering 10% of light speed, the trip still takes about 25 million years in the galaxy's frame. That is not an itinerary, it's a monument to distance. Speed is expensive. Double your speed, and the kinetic energy requirement quadruples. Near light speed, relativity piles on, the gamma factor rises, and the energy curve bends skyward. A 1,000-ton starship at 1/10 of light speed needs energy comparable to centuries of our planet's output before you pay the equally large bill to slow down at the end. What about propulsion? Chemical rockets are magnificent for launches, hopeless between galaxies. Ion thrusters sip propellant efficiently but push too gently for relativistic dreams. Nuclear thermal helps with thrust but not enough speed. Nuclear pulse, Project Orion, could fling vast masses fast at enormous political and engineering cost. Fusion concepts like Daedalus promise higher exhaust velocity, but we have yet to build a single working fusion rocket. Antimatter packs breathtaking energy, but producing and storing grams safely is beyond us. And waste heat would be a killer. Move the engine off the ship. Beamed light sails. Gigantic laser or microwave arrays push an ultralight craft to a fraction of light speed. That could work for grams, or maybe kilograms, but crude habitats weigh thousands of tons, and planetary-scale beam infrastructure must be built, steered, and powered. Staging helps, but propellant mass and waste heat return as unforgiving accountants. And space is not empty. At 1/10 of light speed, a dust grain hits like artillery. At half-light speed, like a bomb. Whipple shields, magnetic fields, and clever geometries help. But every layer adds mass, which demands more energy, which needs bigger engines, which demand more shields. It's a loop that punishes optimism. Relativity offers a strange consolation. At extreme speeds, time on the ship slows. Travelers might experience years instead of millennia. But outside the hull, for the people who waved goodbye, the clock still ticks in millions of years. You don't defeat distance by hiding in your own time. Navigation and communication become epics. Pointing a starship for millions of years is not trivial. Gyros drift, sensors age, and the stars themselves move. Tiny steering errors compound into exile. When you phone home, your message crawls, arriving millions of years after you sent it. And any reply, millions more. Nothing we build lives that long without help. Materials fatigue, computers fail, ecosystems wobble. A ship would need self-repair, self-manufacture, autonomous industry, and cultures that can hand off purpose across unthinkable generations. Before we cross the space between galaxies, we must learn to build things that outlast nations, and maybe species. So what can we do now? Walk before we run. Launch uncrewed interstellar precursors, then faster ones. Learn to live between stars. Master fusion power, high-power beaming, closed habitats, and automated industry. Only then can we discuss intergalactic travel without slipping into fantasy. The universe isn't taunting us, it's honest. The distance sets the challenge, and the challenge sets our work. Start with the nearby stars. Build what lasts. Turn audacity into engineering, and engineering into infrastructure. One day, our descendants may read the sky like a map, know which beams to light, which sails to raise, which habitats to spin, and understand exactly why Andromeda took so long to reach. Until then, its light will keep arriving, stream by ancient stream, reminding us how far there is to go. This you, listening now under one patch of sky, won't ride a ship to another galaxy, but you can help build the staircase. Choose well, learn, design, test, and pass the torch. The cosmos rewards patience measured in centuries, and distances measured in light.